what you have in most medical imaging challenges, you will find something like that. If it's not a challenge, but it's a task that you have to do for a job, you even need to spend lots of time in preparing your data. Here, someone prepared them for you, and that's pretty good. You have two folders. They have the same name, except that one contains GBM and the other LGG. This is high-grade glioma, and the other one is low-grade glioma. These are two different classes, the two different classes that you will need to predict. And in each folder, you have a subfolder. You can see that in Google Drive in the meantime, each of which contains 5 files with these names. These are images in the Nifty format, the one used for neuroscience research. And it's a T1 weighted MRI, a T1 weighted one with contrast enhancement, a T2 weighted, a flare, and truth instead contains a segmentation, a consensus from manual hand-drawn segmentation by 3 radiologists in 3 different classes, which weirdly enough are, well, 0 for the background, 1, 2, and 4, and 3 is missing. So it's 3 classes that way. You just, 3 was supposed to be reserved for future studies. And just to give some confidence in analyzing images, what I'm asking you is try to do a radiomics style analysis using some very basic function with it. There is a library which is called PyRadiomics, where you can extract thousands of features. But here you can install it if you want. It's not maintained as much anymore, but they did an update in 2025 anyway. So, but I'm just trying to see what an analysis would look like. You can try find your own way to classify high grade from low grade, and you should here you read the files using Mibd because they are nifty. It's pretty easy. You just need do this mibd.load, and then you can see it contains some information, much less because Nifty format does not include as many information from the patient, but it does contain a way to orient the matrix of the data. With getF data, you get the actual image matrix, and it's returned in float 64. Think about that when you need to read the labels. Like before, here I'm just asking you to display the image. Then here I'm stopping the code, and you should read the truth and just to familiarize with what's inside. And by the way, think about the format. It's returning float 64, but this is a label, multi-class label, so keep that in mind. And what I'm suggesting you to do is try to read only the T1 CE and try to do some classification. You can just try with the 0 and first order features, so working on volumes and the intensities. But if you're working on the intensity, just remember that you might need to scale that in some way. And then use these couple of features that you come up with to try to do a classification from high grade to low grade. And that's it. Any questions?